briefly. Hey, Rem. We are doing the last bit of 5-2, and I said before we do any of that, I'm going to give you another example, so I have this going on right here. So probability of live is 20%, probability of die is 80%. This is for plants, don't get excited. So my kill rate is 80%. I have part A and part B. If we have 5 plants, find the probability that exactly 4 of them live. Part B is then find the probability that 4 or more live. So this is going to involve a little bit more stuff, okay? We started a probability table, and I said these are the scenarios of what could happen. I could have a 5-0 split. I could have 4-1, 3-2, blah, 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 all the way through. Those are the scenarios that I could have. Now, if my kill rate is 80%, are you guys all listening? If you didn't catch it before. Jace.
What?
Get your stuff out. Write this down. Nope, backside. Flip it over. Put this on there. Okay, if my kill rate is 80%, which one of these is going to happen with the highest frequency? Put this down. Come on.
I see it.
Yeah, I know. You see it. Are you absorbing?
Yeah.
I don't. You are not a sponge. You need to write this down. Okay, a 1 in 4 split's going to happen with the highest probability. So this probability right here is going to be the highest. Normally, this, Megan said normally this looks like a bell curve, where these are the highest ones, but that would be if this is a 50%, like 50% versus 50%. I have a 20-80 rate for kill, or for live die. So 4/5 is exactly 80% for the kill option. Therefore, this probability is going to be the highest one. Does that make sense? Yeah. Okay, so let's figure out how we fill this in. We need 4 things, and that only 4 things. Kellen, we did this yesterday. We have a formula that is 3 pieces. It is NCR. That's the first piece. Times. Do you remember what this is? P to the R power times. The third part is Q to the N minus R power. Those are the 3 pieces, okay? We need 4 different numbers for that. I need to know what N is, I need to know what R is, I need to know what P is, and I need to know what Q is. Okay? All right, this is where it gets a little confusing. In part A, we have 5 plants, and we want to know the probability that 4 of them live. So what is what? N is 5, and R is 4. Okay, now this is where it gets a little confusing. Is everybody listening? Delaney, are you with us? All right. Put your phone away. We don't care.
No one cares.
We don't care. You can do it later. Okay, N is 5, R is 4. Now, 4 was how many were doing what? Hold on. Don't yet, Megan. Because we're going to switch some things. 4 was how many were doing what? Living. I want 4 to live. So what's going to be P?
0.2.
0.2 is going to be P. I want to know how many live, right? Yeah? Q is going to be 0.8. So we've got to make sure that those line up, right? So when I fill out NCR, I've got 5C4 times P, which is 0.2. And how many do I want to live? How many are 0.2? 4. And how many are 0.8? How many are going to die then? 1. That's what I want to fill in. So you got to make sure that whatever your rates are, it's doing that thing correctly, right? Okay. Now, if you fill this in, what is that?
0.0064.
0.0064. So that is 0.0. I'm just going to go 0.0064. When I fill it in the table, I'm not going to do percentages. That is less than 1%. Why is that number so low?
Because it is highly unlikely that 4 of them are going to live.
If I have an 80% kill rate, which is the majority that I'm going to kill, on the chances of 4 out of 5 living,
Why don't you kill them?
that's like,
Just,
I don't water them.
that's probably your problem.
Yeah, I know what my problem is. You tell me how to fix it.
Water them.
I don't.
Self-awareness is the first step. So.
Right. And I am self-aware to know that I do not need any plants in my house because I will kill them. Yep, for sure. It's the ones that don't need watered every day that get me. If they needed watered every day, like, then we would have a different story because then I would be on a schedule, right? But even so, then like, what if I'm gone or whatever? Like, then that throws me off. It's just, But it's like the succulents. They're like, oh, it's hard to kill a succulent because they don't need watered, but whatever. Yeah, then I forget to water them every 2 weeks that they need watered, and then I still kill them. Like, no, I can't do that.
Once I forgot to water for like 2 months.
This I think only gets watered twice a year.
Ooh.
It's still alive.
See, I might be able to actually do that because I just set a reminder on my phone. You know? Like, water the cactus. And then I'd ignore it and ignore it and ignore it for like 6 months, and then it still wouldn't get watered. I don't know. I'd still probably kill it. I don't know. Whatever. Okay. All right. That was part A. A is done. We are done with that. A is 0.0064. Really low chance of 4 out of 5 living if my kill rate is so high. Okay. If we have 5 chance, or if we have 5 plants, find the probability that 4 or more live. So what do I need to do now if I'm looking for 4 or more?
4 and 5.
4 and 5, right? So I'm looking at this one. This is 4 or more, and this is 4 or more. So I need to find this guy and then add them together, right? Yeah. Okay, so part B, I have to do that same thing, all right? So I've got NCR, which is going to be 5C what? We're looking at the live perspective, right? Let's go back up to these. 5C, how many do I want to live? 5, 5C, 5, right? I want 5 to live, okay? My live rate is still 0.2. My die rate is still 0.8. So I have 5C5, 0.2 to the, which one? 5 power. 0.8 to the 0 power. Now, do you know what 5C5 is? 5C5 is 1. Okay, do you know what 8 to the 0 power, 0.8 to the 0 power is? 1. So really, when both of those are zeros, you're really only looking at 0.2 to the 5th power. Does that make sense? Okay, because the other ones are going to be 1s, just as like a little FYI. So 0.2 to the 5th power is going to be
3.2 to the negative times 10 to the negative 4. 'Cause my calculator-
3.2 times 10 to the negative 4, so that's 3 zeros, 0.1, 2, 3 zeros, and 3, 2. So 0.00032. Why is that such a low number?
'cause it's also highly unlikely
If
to
my
kill 5.
kill rate is 80%, the chances that I have 5 plants that live is gonna be really small. So to answer part B, find the probability that 4 or more live. Add them up. 0.00672. Yeah, 0.00672. So is it significant to have 4 or more live? Is it a rare event? Is it a significant event? Why? This thing is less than how much?
5%.
What do we go off of? It's less than 5%. That's way less. That's less than 1%, right? So, yes, it is a significant event. Yes, it is rare for that to happen. Yeah? Okay? So when they ask you further questions, yes, it is a rare event. Now, we could fill this whole table in, right? Like this whole thing in, okay? And those would all have to add up to be how much? 1 or 100%, right? Okay? And again, which one's going to be the highest? The 1 and 4 split, because that's like my kill rate. These two would probably be about the same amount. No, wrong. I don't know.
They'd be close.
Maybe close. It's going to be like if I'm looking at my bell curve here, it's going to do one of these. Yeah? That's what my bell curve is going to look like. It's not going to be symmetric, right? It's going to be like more on that side. It's going to be skewed that direction. Yeah? Okay, so that's how that works. Good? Okay, let's go and do an example. Let's do example 3 together.
You said 5.
What? Oh, should we do 5 together? 5 is kind of an icky one.
This is homework.
We should do 3 and 5 together.
Let's do 3 and 5 together, sure. We'll start with 3. 3 has an ABC. Yeah? Okay, multiple choice questions. Here you go, we're doing homework. Everybody join in now, if you weren't before, Jace. I'm doing your homework for you. All right, number 3. Okay, you have a multiple choice with answers A, B, C, D, E. Okay, if that is true, what's the chances of me getting one correct? I'm not even like answering questions yet. Like if I have an A, B, C, D, E, what's the probability of me getting it correct? 1 out of 5, right? If I guess, right? If you know the answer, like obviously your chances are higher, but if you guess, it's a 1 in 5 chance of getting it correct, okay? Assume that you guess the answers to 3 such questions, okay? So now we have 1/5 times 1/5 times 1/5 again, right? Okay, we're doing 3 questions. All right, use the multiplication rule to find the probability of, probability of correct, wrong, correct, right? So I have 3 multiple choice questions. What's the chances that I get this one correct, that I get this one wrong, and that I get this one correct? Okay, so what's the chances that this one is a correct answer? 1/5. What's the chances that the second one is a wrong answer? 4/5. The chances that the third one is correct? 1/5, okay? If I multiply those tops together, 1 times 4 times 1 is 4 over 5 times 5 times 5? 125, okay? And let's go ahead. I'm going to write 4 over 125, but let's do it as a decimal now.
0.032.
0.032. Okay? Good, good. Okay, beginning with correct, wrong, correct, make a complete list of the different possible arrangements of 2 correct and 1 wrong answer, okay? So now, I want just 2 correct answers and 1 wrong answer, plus 1 wrong. Hey, Ram, 2 correct and 1 wrong. So that means if I want 2 correct and 1 wrong, I could have gotten CWC, or it could have been something else. Just set it on my desk. Or it could have been something else. What's another combination?
CW.
CCW. Okay, give me another one.
WCC.
WCC. Anything else? Is it just those 3?
I think so.
2 correct and 1 wrong? Yeah. That is 3 of them, okay? Now we have to find the probability for each entry in the list. So we just said this one had a probability of 4, or let's go with the decimal. That one had a probability of 0.032. What's the chances that, like, what's the probability of the second one combination happening? Is it not the
I
same?
think it should be this. Yeah.
Because it would be 1/5 times 1/5 times 4/5 again.
Yeah.
Isn't that going to be 0.032 again?
It will be
Yeah? What about the third one? Wrong, correct, correct.
the same.
Also 0.032. Yeah? Okay, so what's the chances that I get 2 correct and 1 wrong in any order?
That.
What?
0.032. No.
Point what?
0916.
Not 16. 0.096. If you add all 3 of them up, yeah. Because I could get any one of those combinations. We're on number 3. I'm still recording, Rem. Yeah, on the homework. Okay? All right, because I could get any one of those combinations to happen, 2 correct and 1 wrong would be the result of all of those happening, right? So almost 10% chance of getting 2 correct, 1 wrong, right? Okay? Now, we're going to, instead, based on the preceding results, what is the probability of getting exactly 2 correct and 1 wrong answer when you have 3 guesses made? We're going to do this using the NCRP to the R, Q to the N minus R method, okay, and see what we get, all right? So NCR, we have how many questions? 3, and I want to get how many correct? 2 correct, okay? P is the probability of me getting those correct, right? What's the chances of me getting it correct?
0.2.
0.2, which is 1/5, right? That's 1/5, okay? And I want 2 of those to be correct, right? What's the chances of me getting it incorrect? 0.8. And how many of them am I going to get incorrect? 1. Okay, plug that into your calculator and see what you get. This is why we can't have mixing. What?
0.096.
Oh, man, look at that. 0.096, just like we got up above.
Did you guys do the last example? Or
Not yet. We did a different example. I'll show you here in a second. Okay, do you see why those 2 things should match? When your calculator is doing this formula, it's doing that process, right? In any order, it's adding all of those in any orders together. Yeah? That's how it works. Good? Okay, we did this example, Remington. I had them write down a new example on the back page. Okay? Yeah.
I'll write that down.
Okay, let's do number 5 together. Here we go. A binomial probability experiment is conducted with the given parameters. Use technology to find the probability of X successes in N independent trials of the experiment. We don't even know what we're talking about yet. Maybe we're talking about killing plants. Maybe we're talking about something else, right? Okay, but we have N and R and P and Q, okay? All right, and I'm going to get my table ready to go here. Zoop. And let's go P of X, okay? So if we have 8 things, I don't even know what we're talking about. So let's just say
Yes.
yes, no, sure. So we could have an 8-0 split. We could have a 7-1 split, a 6-2, a 5-1, a 5-3. I can't do this. A 4-4 split, a 3-5, a 2-6, a 1-7, and a 0-8. Heaven forbid we have to fill this table in completely. Yikes. Okay? The probability of yes is 25%. Okay? If my probability of yes is 25%, this is no longer going to be a bell curve like this, right? My highest is not going to be the 4-4. The highest would be a 4-4 if P was what? 0.5. If my probability was 0.5, 4-4 would have the highest probability right here. Okay, but it's not. My probability of yes is 0.25. So which one of these over here is going to have the highest, like, number over here? 0.25 is my P. Probability of yes. 2-6 probably, right? 2-6. This would be a 2 out of 8. And that's going to have the highest probability. This one's going to be the highest one. So my bell curve is not going to look like a normal bell curve. It's going to be like this. Like that. Skewed a little bit to the right, or technically left skewed because it's opposite, right? Okay. All right, so they want to know, though, the chances of it being less than 4. Okay? All right. So we're looking at yeses specifically. Is this one less than 4? Is this one less than 4? Less than 4. Less than 4. Less than 4? No. Is this one less than 4? Yes, I want that one, that one, that one, that one. Those are all less than 4s for the P. Yeah, yeah? Okay, so I have to plug these combinations into my formula, get those probabilities, and add those 4 numbers together. This is where it gets kind of messy, okay? All right, N, R, P, Q. N is how many? Let's do this combination right here. N is how many?
8.
8. R is?
Oh,
R is 3, okay? P is?
0.25.
0.25. Q is? 0.75. So for this combination exactly, I'm doing 8C3. That's the first chunk. Times 0.25 to the what power? 3. 0.75 to the what power?
The 5th.
The 5th power. Yeah, yeah. Okay, that's that one.
I got
0.2076.
0.2076?
Yeah.
Okay. 0.2076. Now, when I do 2 6, is it going to be higher than that one or lower than that one? When I do the next one, is it going to be higher than that one or lower than that one? Higher, because we said that this combination should be the highest one, right? Okay. All right, so in this next one, we're doing 8C2 times 0.25 to the 2, 0.75 to the 6, right?
0.3115.
0.3115. Okay, that's that one. Now, if I do 1 and 7, formula stays really similar. 8C1, 0.25 to the 1, 0.75 to the 7. If you have this in your calculator and you just go back into the formula and just swap those numbers out, that makes it easier. What you got?
0.2669.
0.2669. Hey, was our theory correct that that one was going to be the highest probability? Yeah, yeah? Last one, 8C0 times 0.25 to the 0 times 0.75 to the 8. Okay, now again, 8C0 is the same thing as 8C8. How many ways can you choose 0 of 8? 1. Yeah, it's choosing none, right? What's 0.25 to the 0 power? 1. So really you only have to worry about 0.75 to the 8th power.
Which is 0.1001.
0.1001. Okay, now I want to know the probability of getting less than 4. So I add those all up. Boop. It's going to be like the majority of the time. 60%, something like that. 70% even. Point.
8 88617.
88617. Yeah, so 88% are from there below. Okay, does that make sense? Yeah. We didn't even do half of the numbers in the table, right? There's 9 different combinations in the table. We only did 4 of them, and we got 88%. Why is this half of the table so much smaller? Why will these numbers in the table be so much smaller?
Because it's skewed up.
Because 0.25 is representing like closer to this half of the table, right? 0.25 is going to be like skewed to that section. Okay, do you see how this works? Your table will no longer be symmetric unless your P is 0.5. That makes sense? Okay. If it is 0.5, then your numbers here should match your numbers here. It should be exactly perfectly symmetric. But this one's not going to be. It's 0.25. Yeah? Does that make sense? Okay, kind of messy. Now, number 4 is really nice. I'm going to read to the end. It says, find that the number of successes is exactly 1. That's really nice because you only have to do this formula 1 time. When they say the number of successes is less than 4, you have to do 3 and 2 and 1 and 0 and add all 4 of those together. Does that make sense? Okay, so when they say the number is exactly 1, that's nice because I only have to do the formula once. Yeah, you just have to find NPQR. Yeah? Okay, I was going to do example 3, but I think we're snowed. Are we snowed? Yeah. Okay, do number 4, do number 2, do number 1. On the back side, you should be able to do number 6 and 7 probably. Yeah.
Up to 3 and just like standard first.
Yep. Okay, do the rest of those guys. All right, you should be able to do all the rest on the first page and then like number 6 and 7 on the back page. Okay, do it while it's in your brain. Maybe it's not in your brain. It is? Okay. Set up your formula. Are we snowed, Hallie? You look overwhelmed. Okay. Rem, I'm going to stop recording for you.